So we were studying about dual nature of radiation and matter, right? NEET numerical, right? So first topic, write the topic name, dual nature of radiation and matter, right? So now see the next numerical, that is third one. That is for which one of the following Bohr's model is valid, right? We are talking about Bohr's model. So Bohr's model is valid for hydrogen-like atom only, right? So it is asked in 2020. So, so singly ionized neon has electron counter more than one electron. So Bohr model is valid for atom with single electron. Okay. So Bohr's model has talked about only is valid for one electron only for atoms with single electron. So remember this statement. Okay. Next question is fourth one. Energy equivalent to 0.5 gram of substance. So mass of substance is given m equal to 0.5 gram. So we have to find the energy equivalent. So what will be the energy associated with this mass? So right, we know the energy formula E equal to mc square when it is related with mass. So mass we know, right? 0.5 convert into kg. So 0.5 divided by 1000. So it will be in kg. So it will be equal to 0.5 into 10 raised to minus 3 kg. So 10 raised to minus 3. And C is the speed of light. So it is 3 into 10 raised to 8 whole square. So E will be equal to 4.5 into 10 raised to 13 joule. So this will be the energy associated with this mass. So this is asked in 2020 second phase. So write about it. See the next numerical, fifth one. Fifth one is talking about light of frequency. So frequency of light is given is 1.5 times that threshold frequency. So this is 1.5 times of threshold frequency. So I will represent threshold frequency as f naught, right? So frequency of light will be 1.5 times of f naught. Is incident on photoelectric material. So this is incidenting on the photosensitive material. This is your photosensitive material. So what will be the photoelectric current if the frequency is half? So what will be the photoelectric current if the frequency is half? If we do the half of that photoelectric current, so electron is ejecting from here. So it equal to kinetic energy 1/2 MV square. So that is called photocurrent also. So its frequency, photoelectric frequency is half and intensity is doubled. So intensity of that will be doubled of that one, threshold one. So see here. So suppose this will be FL equal to, I will remove this point. So it is 15/10 F naught. So cancel with the 5. So it is 3/2 F naught, right? So this value we know, right? This will be equal to FL. So put here FP will be equal to 1/2. FL we know that is 3/2 F naught. So it will be equal to 3/4 F naught, FP. So clearly you can see, right? Whose value is greater? So you can observe F naught value is 1 Fill value is equal to 1.5 F naught, and Fp will be 0 by, this will be how much? 3 by 4. So it will be 0.8 almost, right? So you can observe which one is greater. So a fill, if this one is a fill now, F naught is greater than a fill, right? And the smaller one is Fp. ये समझ में आया सीक्वेंस रिजल्ट? Have you understood this one?
No, sir.
Okay. I am finding the relation between this one. Suppose this frequency of light is striking on this photoelectric material. So this will be the initial kinetic energy, right? And this will be the work function of this material. That is threshold frequency. This is called threshold frequency, right? Simple hai. So this initial kinetic energy is falling down on this material. So it is having kinetic energy. Suppose I have taken Ke E naught, right? And after getting a strike, after some time, it is ejecting the final kinetic energy, that is 1/2 mv square. So in the similar manner, I am relating this with the frequency. So this initial kinetic energy frequency I have taken as FL, that is equal to 1.5 times of F naught, right? So times of F naught. So it will be 1.5 F naught. Understood? So this is ejecting the electrons of half of that FL, this one. So I have put the value of FL, that will be 3 by 4 F naught. Understood now? So I have written the all value F naught, FL, Fp. So which one is greater? FL na? So I have
Got
written
it.
in the sequence value. ये समझ में आया तुम्हें?
हाँ सर.
ओके, नहीं समझा तो एक बार और बताता हूँ. देखो, ये आपका मेटल सरफेस है, ठीक है? इसके ऊपर एक एनर्जी गिर रही है, E इक्वल टू एच म्यू. म्यू फ्रीक्वेंसी है, म्यू इज नथिंग बट फ्रीक्वेंसी. तो फ्रीक्वेंसी जो है ये म्यू, ठीक है, वो है तुम्हारा 1.5 टाइम्स ऑफ म्यू नोट, और ये मेटल का फ्रीक्वेंसी है म्यू नोट. तो इसका एनर्जी जो मेटल का है वो है एच म्यू नोट. समझ में आया? और ये जो एनर्जी मेटल के ऊपर गिरेगा तो यहां से इलेक्ट्रॉन निकलना चालू होगा एक टाइम के बाद, ठीक है? तो उसको बोलते हैं हम लोग ई फाइनल. तो उसका एनर्जी होगा ई एच म्यू एफ फाइनल. ये समझ में आपको भी? तो इसका
हाँ
जो
सर.
फ्रीक्वेंसी है म्यू एफ, वो है म्यू का हाफ. तो म्यू का वैल्यू पता है 1.5 म्यू नोट है डिवाइडेड बाई 2. समझा? तो विच वन इज ग्रेटर, वी आर फाइंडिंग इट, राइट? सो म्यू इज ग्रेटर देन म्यू नोट, greater than mu f. So this is the final frequency. So I have written here energy in the all the form in mu. Mu means frequency. समझ में आया? जैसे मैं तुम्हें रियल प्रैक्टिकल एग्जांपल समझाता हूँ. ये आपका रूम है, ठीक है, स्टडी रूम. तो यहाँ पे आपने लाइट ऑन किया है, ठीक है? यहाँ पे कोई मेटल है या मैं बैठा हूँ, तो एनर्जी लाइट गिर रही है. मैं 24 घंटा से एक ही रूम में और लाइट बहुत सारे मेरे ऊपर गिर रही है. तो एक टाइम के बाद मेरा एनर्जी जो है टेम्परेचर वो बढ़ जाएगा ना, मतलब एनर्जी बढ़ जाएगा. तो एक टाइम के बाद क्या करूंगा, मैं इलेक्ट्रॉन्स निकालना चालू करूंगा, ठीक है, एनर्जी के फॉर्म में. तो ये एनर्जी इस लाइट ऑफ सोर्स से आ रहा है ना, तो जिसके ऊपर गिर रहा है उसको थ्रेशोल्ड फ्रीक्वेंसी बोलते हैं या वर्क फंक्शन बोलते हैं. वर्क फंक्शन. ठीक है, ये समझ गया तो पूरा केमिस्ट्री का कंसेप्ट समझ जाओगे। ये समझ में आया आपको अभी?
हाँ सर।
ओके, सो राइट दिस वन, प्रीवियस वन। तो इसके अंदर क्या पूछ रहा था कि ये जो एनर्जी है ना आपका, इसका वैल्यू ज्यादा है, देखो यहाँ पे। तो इसका एनर्जी ज्यादा है तो इसके मेटल के ऊपर गिरेगा, राइट। तो इसके ऊपर गिरेगा तो ये एनर्जी एब्जॉर्ब करने के बाद ये फ्रीक्वेंसी का एनर्जी बाहर निकालेगा। ठीक है, ये वाला फाइनल। तो ये सीक्वेंस बराबर है, ये करेक्ट सीक्वेंस है। मतलब इसका वैल्यू ज्यादा ही होना चाहिए, मैक्सिमम होना चाहिए म्यू का, ग्रेटर देन म्यू नोट। अगर ये उल्टा मैं तुम्हें कर दूं ना, अगर म्यू नोट का वैल्यू ज्यादा है म्यू से, तो ये इलेक्ट फोटोन करंट नहीं निकालेगा, फोटो इलेक्ट्रिक करंट नहीं निकालेगा, राइट। क्योंकि कम अमाउंट का अगर एनर्जी आपके ऊपर स्ट्राइक कर रहा है तो आपका टेम्परेचर बढ़ेगा ही नहीं। ठीक है, जो नाइट लाइट होती है वो, उसका देखो टेम्परेचर कितना कम होता है ना, उसमें से कितनी कम लाइट निकलती है, राइट। तो उसमें से तुम्हारा टेम्परेचर रूम का नहीं बढ़ता है। ठीक है, जो हम लोग ज्यादा एनर्जी का जो लाइट लगाते हैं उससे एनर्जी निकलेगा। ये समझ में आया आपको? तो ये सीक्वेंस याद रखना है, ठीक है। अगर मैं आपको ऑप्शन दिया कि म्यू नोट इज ग्रेटर देन म्यू, ग्रेटर देन म्यू एफ, तो ये करेक्ट ऑप्शन है? नहीं। अगर मैं आपको दूं म्यू ग्रेटर देन म्यू नोट, ग्रेटर देन म्यू एफ, तो ये करेक्ट ऑप्शन है, ठीक है। अगर और जम्बलिंग कर दूं म्यू एफ इज ग्रेटर देन म्यू नोट, ग्रेटर देन म्यू, तो ये ऑप्शन करेक्ट कैंसिल है, राइट। तो सीक्वेंस करेक्ट वही यही वाला है। इनिशियल वैल्यू ज्यादा होना चाहिए, राइट। मिडिल वाले का वैल्यू रेंज ये दोनों के बीच में होना चाहिए। जैसे अगर मैं न्यूमेरिकल वैल्यू ले लूं, तो मान लीजिए इसका हर्ट्ज फ्रीक्वेंसी का ज्यादा होना चाहिए एज कम्पेयर टू 400, एज कम्पेयर टू, ये ज्यादा होगा तो ये 200। ठीक है, ऐसे सीक्वेंस में याद रखना। ठीक है, हमेशा बड़ा होना चाहिए। ये कंसेप्ट बहुत इंपॉर्टेंट है फोटो इलेक्ट्रिक के लिए, और इसी से क्वेश्चन आएगा आपको। ठीक है, आगे बढ़ते हैं। अभी देखिए सिक्स सम सॉल्व करते हैं। इलेक्ट्रॉन इज एक्सेलरेटेड फ्रॉम रेस्ट थ्रू अ पोटेंशियल डिफरेंस ऑफ v वोल्ट। ठीक है, इलेक्ट्रॉन जो है रेस्ट पे है, मतलब इनिशियल वेलोसिटी उसका 0 है, पोटेंशियल डिफरेंस है v। इफ द डी ब्रोगली वेवलेंथ ऑफ इलेक्ट्रॉन is nanometer, so lambda of de Broglie is given, that is 1.227 into 10 raised to minus 2 nanometer. Potential is V is your potential. So what will be the potential value? Potential difference. So we will use the lambda formula from de Broglie. Lambda equal to 12.27 Armstrong divided by under root of V. So under root of V is potential difference. Potential difference. So remember this one, potential. So we have to find this one only, right? So take here in numerator form, del under root of V is equal to 12.27 Armstrong divided by lambda. 12.27 Armstrong means 10 raised to minus 10 meter. So right here 1 Armstrong is equal to 10 raised to minus 10 meter divided by V. Lambda value we know, right? That is 1.227 into 10 raised to minus 2 nano. 1 nano meter means 10 raised to minus 9 meter. So it will be equal to 10 raised to minus 9. So calculate this value. So it will be approximately equal to how much? So we'll solve, right? So remove these points, you will get here 100. Remove these points, so you'll get here 1000, right? So this will be cancelled by this. So remove these 2 points. This is 10 raised to minus 2, 10 raised to minus 9, right? So this will be cancelled by this. 1 will be remaining here, right? So it will be 100 under root of V, right? So when we are squaring both sides, so we'll get V equal to 100 raised to 2. So it will be equal to 40, right? This much. So this will be the potential for threshold or for de Broglie wavelength. So write this one. This is asked in 2020. Look at the seventh one. Total energy of electron in the nth stationary object of hydrogen can be obtained by. So we have to find the total energy. E of total equal to of nth stationary object can be calculated. So it is asked in 2020, right? Seventh one. So for this one, we have to find energy. So it is equal to given by directly minus 13.6 electron volt upon n square. If it is different atom, so write here Z. Z is nothing but it is atomic number. Suppose I am taking sodium, so atomic number is 11. Taking potassium 19. So Z is 19. So it depends on the atom we are taking, right? And N is number of orbit. So suppose I have taken sodium, so it is having electronic distribution is 2, 8, 1. So suppose I am talking about third orbit. So here N will be 3. This is N equal to 2 for sodium. This is N equal to 1 for sodium, right? So N value will be varying. It will be told clearly to you. So it is talking about hydrogen, right? So hydrogen atomic number is 1. So Z will be 1. So put in this final energy. So it will be equal to Et equal to minus 13.6 electron volt into 1 square divided by n square. So final equation will be this for hydrogen atom. This is asked in 2020 in second phase only in NEET exam. Next numerical is 8.1. An electron is accelerated through a potential difference of V value it is given, that is 10,000 volt. De Broglie wavelength is nearly. Mass of electron is given, that is 9 into 10 raised to minus 31 kg. This is asked in 2019 in NEET exam. Right. So we have to find the what? Wavelength. De Broglie wavelength. So what is the formula? Can you tell? In the previous question, I have told now lambda D equal to 12.27 Armstrong divided by under root of V. So remember this formula. This relates wavelength, potential difference, right? So we have to find directly lambda D, de Broglie wavelength. That is 12.27. Armstrong is 10 raised to minus 10 meter, and it is given 10,000, right? So 100 will be coming out, right? 10 raised to minus 10 meter divided by 100. So take in numerator, so it will be 10 raised to minus 12 meters. So 10 raised to minus 12 is called pico. So it will be 12.27 picometer. 1 picometer means 10 raised to minus 12 meters. So remember this one. So this is the answer for this question. The next numerical, that is ninth one. So ninth question. An electron of mass m. Electron of mass is given m with initial velocity v is equal to v naught I. ठीक है, enter in electric field, that is E equal to minus E naught I cap. ठीक है, E naught is constant. If lambda naught is the de Broglie wavelength initially, then its de Broglie wavelength at time t is given. So we have to find the lambda d, means de Broglie wavelength. De Broglie wavelength. ठीक है, that is equal. We have to find it. So remember the formula I will write here in sequence form. So F is nothing but force. How it is related? Equal to E into minus of E naught I cap. So this minus and this minus will get into plus. So it is equal to E naught I. I means x-axis. I is nothing but unit vector. Suppose I am taking here x, y, z axis. So I unit vector is I. For y it is defined as j. For z it is k. So all these are unit vector. Unit vector. Understood? So this is how force and electric field is related. So next one is acceleration. So A is defined as force upon mass. So F value we know from the first equation. Put here E naught I divided by M. So A is nothing but acceleration, right? This is defined from Newton's second law. Newton's second law. So next one is total velocity we have to find. So total velocity is given by mu naught plus. So velocity is nothing but displacement upon time. And how acceleration is related? A equal to V by T. So when we have to write in acceleration form, so V will be equal to AT. V equal to A into T. So put here. So it is initial velocity. So next will be Vt. So Vt value I will write here. So it will be A into T. So V naught plus A value we know from second equation. So put here, right? Here. So A is nothing but it is E naught I divided by M into T. So this will be the final resultant velocity. Right? Now we know the lambda equation. So lambda is equal to H upon P. H upon P. P is momentum. So momentum is nothing but mass into velocity. So it mass into velocity. So put here Vt value, right? From this third equation in fourth. Right? So you will getting the final equation. Lambda is equal to H upon M. Right? V naught plus, right, in acceleration form. So it will be E naught T by M. Understood? If you want to cancel it, so take all these inside. Or you can write up to this point only. So now see the next numerical. That previous one is asked in 2018, right? So next question from NEET 2018 only. Next one is 10th one. That is when the light of frequency 2 mu naught, right, is incident on metal surface. So it is a striking on the metal surface. This will be given as mu naught, right? Frequency of this. The maximum velocity of electron emitted is V1. So electron is ejecting from here. So kinetic energy is 1 upon 2 m V1 square given. V1 is the velocity through which electron is coming out, right? When the frequency of incident radiation is increased by 5, right? So this is the first case. So it is talking about now it has increased the frequency 5 mu naught and it is striking on the metal surface. Its initial frequency will be mu naught only. So maximum velocity of the emitted phase will be, so here kinetic energy again coming out m V2 square, right? So we have to find the relation between V1 and V2 asked in 2018. So this is another case, second case, right? So just solve it, write the kinetic energy formula. So photoelectric equation is also called Einstein equation. So I will write here Einstein equation for photoelectric. Einstein equation. So it is given by 1 upon 2 m V1 square equal to 2 h mu naught minus H mu naught. So this is initial kinetic energy. This is threshold kinetic energy. Threshold means pi naught. And this is your final kinetic energy. So final is given by initial minus work function of the metal. Understood? So write for the second one also. So this is the first. Now second, it will be 1 upon 2 m V2 square equal to 5H mu naught. Are you getting how I am writing here 2 and here 5? Because it is already given in the question. So it will be 5H mu naught equal to H mu naught. Understood? So subtract this. So it will, you will get here H mu naught. H mu naught, and here it will be 4H mu naught. So you have to divide first equation by second. So divide. So m and m will get cancelled, and these two. So it is equal to 1 V1 upon V2 whole square equal to. So H mu naught get cancelled. 1 upon 4. So for finding V1 by V2, we have to take a square root. So it is equal to 1 upon 2. Understood? So ratio will be 1:2. Now next numerical, 11th one. Okay. So now see the next numerical 1811. It is asked in NEET 2017. De Broglie wavelength of neutron in threshold equilibrium will be heavy water at temperature T. So it is talking about neutron. Neutron wavelength in threshold in thermal equilibrium. Thermal equilibrium with heavy water. With heavy water at temperature T. And mass is given m. So as we know de Broglie equation, how lambda and momentum is related, lambda equal to h upon p. So we can also write in mass and energy form, C is equal to h upon under root of 2me. Right. And energy is given by nothing, it is 3/2 kT. So when energy depends on the temperature, so put here E value. So it is h upon under root of 2m 3/2 k into t. So these two and these two will get cancelled. So what will be the value? H upon under root of 3m kt equal to lambda. So this will be the threshold value in the form of temperature, right? So remember the formula here. You have to just mind it. This one, and this 3, and this will be the final equation. So remember these all 4 1.